San Francisco is home to some of the most innovative companies of the 21st century. This pioneering and forward-looking spirit is alive in San Francisco government as well. The new headquarters of the San Francisco Public Utilities Commission at 525 Golden Gate Avenue is more than just a 13-story government office building. Instead, innovative city leaders, departments, and project managers joined forces with local architectural firms KMD and Stevens Associates to build one of the greenest office buildings in America. It's more than a building, it's a living system.
Fortunately, the world suddenly had wind turbines, which they didn't have before. And so our team, realizing that time had changed and realizing where the opportunities were today, scratched their heads one day and said, you know, what we started out as really something to control the wind was an asset that when you combine today's technologies becomes something entirely different.
Wind turbines in an urban environment is a relatively new concept. There are a few buildings in other major cities where they have installed wind turbines on the roof.
And wind turbines on buildings aren't really perfected yet. The discussion was, do we do that or not? And the answer was, of course. If they're not perfect yet, we're building a building that's going to last 100 years, and in 100 years, someone's going to perfect really efficient wind turbines, and if these aren't right, we'll replace them. We have time to do that.
The building has 2 renewable energy generation. There are wind turbines located on the north facade and 3 different levels of photovoltaics.
We have over 600 solar panels at 3 platforms on the building and 4 building integrated wind turbines. The wind turbines and the solar panels produce 7% of the building's energy, and we're reducing the use of energy here by 32% over a typical office building.
The entire building is controlled by a complex computer system which monitors and adjusts air, heating, and lights, as well as indoor shades.
The building is going to be a smart building. It's going to have all integrated features. So it has a monitor on the roof that knows where the sun is. As it gets warmer or colder, it heats and cools the building. As it gets lighter, shades can go up or down to make sure that you're not overusing any kind of heat or air conditioning, but as it gets darker, the shades can go back up. The lights inside the building self-adjust depending on how close they are to the light source of outside, how light it is, how dark it is, and so you're not using energy more than you need.
The keys to this building is that we're maximizing the use of natural daylight to light the building. Here on our south facade, we have light shelves. These light shelves help to shade the floor, but as well, light bounces off of the light shelf into the interior of the floor, providing more daylight into the interior of the floor. Lighting is both the greatest use of energy consumption in an office building, but it also contributes to the largest amount of heat gain in the building. We're maximizing the use of natural daylighting. We also have light sensors that minimize the use of artificial lighting.
And the way they work is you have a shared elevator call button in the lobby. You would indicate which floor you are going to, for instance, like 3, and it will direct me to elevator C. So I'll go to an elevator with people that are going to that same floor. What's also interesting is inside the elevator cab, there are no floor selection buttons because I've selected my floor in the lobby. This takes some getting used to as we're all accustomed to choosing our floor inside the elevator cabs.
One of the things we're going to have in that building is going to be this media wall in the lobby. And that media wall has several things that it can show people, but one of the things it can show our employees and our visitors is how much energy, how much water, what we're using in the building.
So the right side of the wall is based on building data. We have total energy use per floor. We also have energy use in the building today. It'll show information and percentages on how much is being used today versus an average day. There's also information from solar, how much solar the building is producing, and showing the savings from solar. We also have reclaimed water at the SFPUC building, and that will also be shown here per month. The center section is dedicated to water, wastewater, and power. So we have live information showing us how much wastewater has been treated so far from the night before. There's also Twitter feeds and information that anyone that comes in can see, just current news and information from the Twitter. There's also BART information. When's the next BART leaving? When's the next train departing? And there is weather at Hetch Hetchy and also weather at San Francisco.
The digital arts wall is comprised of 54 feet of 160 high-definition monitors that has a 3D motion detection that allows you to approach the wall and then to look at the content that is there in front of you, which is a beautiful artistic narrative. And then as you move towards it, it activates deeper content that comes up.
This is one of the main applications we developed with the communications team at the PUC, and it's called Snowfall to Outfall. And it's about the water cycle, how the water comes down from the snow in the Yosemite, melts into the reservoir, then gets treated, produces power, comes all the way down to the city, and then gets discharged as clean effluent once it leaves the bay. We developed a motion tracking system with 4 cameras on the ceilings here, which detects people when they approach the wall and presents information pop-ups. So you can enjoy it from a distance as a landscape, but then once you get up close, there's another level of information that's educational about this.
Firefly by Sebastopol artist Ned Kahn is an art installation which rises straight from the Golden Gate Avenue sidewalk to the top of the building.
The Firefly wall will be 5x5 polycarbon plates that will move with the wind and show like a wave effect in the daytime. When those also swing back and forth, when they hit the fulcrum, they will also set off an LED light that will be the color of a firefly. So at nighttime, people in the northern part of San Francisco can see the side of our building, and about 20 feet wide and 10 stories high will be a wall that will flicker on and off like fireflies at nighttime. It will be so energy efficient that if all those lights were on, it would be the equivalent of a 40-watt bulb.
And I saw the new piece of artwork going all the way down the side of the building, which looks like this incredible wind ripples on a pond. And I thought, oh my God, how incredible, how wonderful.
Inside the building, we will have water walls in the main staircase, and the water will be dripping through the side of the wall. You'll be able to hear it, you'll be able to see it. We put out a call to San Francisco artists and San Francisco galleries and said, hey, we want a building that is a place people want to come to work in and to visit. We're now going to be buying art from between 80 and 100 local artists in San Francisco, and the Arts Commission will be hanging that art over the next couple of months for the.
And this is the most energy efficient government building in the United States today, if not the world. And it is an example that the entire United States can look to and say, that's what we need to do to save our city hundreds of millions of dollars in energy consumption a year, and set an example to everybody of how to save energy, to be green, to be sustainable, to be responsible. The city is leading the way.
It will be immediately recognizable and iconic from various parts of the city, or even when you see a picture of it, you'll say, that's the SFPUC building. My God, isn't that a wonderful building? Didn't they do it right?